We'll start off with a quick video to finish up 4.1. In 4.1, we saw a lot of the probability notation, got the idea of the classic approach to probability, as well as saw that empirical probability idea that's really the basis for the rest of this course. The last piece of 4.1 is talking about our basic probability rules. Most of these are common sense or things you know already. If something is no way can happen, then we say the probability of that occurring is 0. If something is guaranteed to happen, then our probability is 1 or 100%. I mentioned this only for this third bullet here. If you give me a probability, it better be a value between 0 and 1. If it isn't, I usually will double dock you out of anger, sort of like I would on the correlation questions, right? If you give me out something that is not a feasible probability, I will be even more angry than even if all of your work looks pretty good and then you give me 1.3, I'm going to be angry and dock you more points than I normally would. The only other piece of this 4.1 that we need to sort of talk about is the notation we use to denote not A, so something that is not that event happening. We have a first idea of a Venn diagram, so we usually draw our little Venn diagram, as you can see here, with a box to denote the entire sample space. So the entire box is usually sums to a probability of our sample space, which is just 1. That's every single thing. And then in this particular Venn diagram example, not much of a Venn diagram. We only have event A, and then everything that's not an A we call a complement. And we happen to use the notation here. I like A with a little c as a superscript, which means everything not in A. You are also welcome to just write not A out if you like that better. And in some textbooks, they use a bar to denote not A. But to me, that's really confusing, especially with our means having a bar over them. So I do not like that notation. I prefer one of those other two. But if you were in someone else's class and they were using a textbook that used that notation, I just want you to have seen it before and realize that is another way to say the complement. So we found earlier in 4.1 that the probability of rolling 2 dice that sum to 7 was 6 events out of the 36 events in the sample space, or 1/6. Then the probability of rolling 2 that don't sum to 7, well, the probability of our A complement must just be 1 minus that. It must be a 5/6 chance. So this is a formula I won't be giving you on the exam because to me it's normally a common sense type question. If 30% of students, I have no idea, go to the CT sessions, that means 70% of students do not go to the CT sessions. Very much common sense. So this finishes 4.1 and we'll jump in with 4.2 next.